Hello everyone, this is Dr. Esperanza and I am going to be working on arithmetic and geometric sequence. You're going to be sitting in my classroom with my students in algebra, and for today we're going to be working on arithmetic and geometric sequence. So if you need more information and you need more practice on working with problems like this, stick around and sit in my classroom today. Alright, good morning. So today we're going to be working on arithmetic sequence and geometric sequence, and this particular lesson can be extremely complex or extremely simple if you know what you're doing. And it's all about recognizing the formula to use and also understanding how to answer certain questions, because it all boils down on how you answer math problems. And if you don't know how to answer math problems because you're not understanding the question, then even if we have the formula right in front of you, you're not going to be able to use it. So let's talk about sequence and series. And in sequence and series, it's all about number patterns. And number patterns, just like what we are seeing right now, we have a series or a sequence of numbers right here and right here. And if we're going to guess, we're not doing any mathematical calculation, but just looking at the numbers that we have for the first set of sequence of numbers, we have 0, 3, 6, 9, 12, and 15. What do you think would be the next three numbers would be in this sequence? 18, 21, so it is 18, 21, 24. Now, if we're going to articulate or describe what happened or what is happening in the sequence, how are you going to articulate it? Adding 3 from where? Because you need to start somewhere.
3 plus 0 is 3.
3 plus,
Yeah, that's right.
3 plus 0 is 3.
3 plus 0 is 3, and 3 plus 3 is 6.
6.
So what is the pattern in this sequence? Adding 3, starting from what number?
0.
There. And that's basically how you formulate a pattern in mathematics. You need to know where you started, and you need to see the pattern or the constant that you're adding or multiplying or dividing or subtracting to the sequence, so you can come up with a description for the sequence. And in this case, adding 3 starting from 0. So this is the very basic description on this sequence, right? We're just describing sequence. We're not doing any math. We're not using formula, okay? So we're like looking at the problem as if you have to solve. All right, number 2. We have 5, 3, 1, -1, -3, -5, -7. If you're going to guess the next 3 numbers of this sequence, what would that be?
-9,
-9,
-11,
-11,
-13.
and that is correct. Now, you need to describe the pattern in this sequence. Just like how we did on the first set, how are you going to write your description on the second set?
-2 starting with 5.
-2 starting with 5. And to make it more descriptive, it's basically subtracting 2 starting from 5, right? So in mathematics, it needs to be in a form of a pattern, and when you are working with rules and pattern, it needs to be described in a more systematic way. And the system that I'm showing you here is that we need to start somewhere, and then you need to know what is happening on the succeeding numbers to be able to come up with that pattern. And on number 1, we add 3 starting from 0, and on number 2, we subtract 2 starting from 5. So that is what's special about the sequence and the pattern of this number. And now, since we know how we can describe the pattern to a certain sequence, sometimes we produce a mathematical formula that we follow so that we can produce the sequence of number in mathematics. Just like this example. Find the first 5 terms of the sequence. So what we're going to do is, you're not seeing the sequence of numbers just like what I showed you on the first slide, but here, they want you to produce the first 5 terms of the sequence with this rule. And the rule is 2n minus 3. That's the number that you are going to be producing. So, if I'm going to be producing the first term, and in mathematics it's all about codes, it's all about formula, and we're naming each of the term with a code. And the code is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. Just to make sure that you know what we're looking for. And if we're going to be finding for the first term, we're going to use this formula to produce the first term, which is 2n minus 3. And in this case, n is 1, right? So we will replace the n with 1. And then we'll do the math. 2 times 1?
2.
Minus 3? Negative 1. So that is the first term. Now, the question is, find the first 5 terms. So can you please complete this problem? Give me a sub 2, a sub 3, a sub 4, a sub 5. You produced it?
I think so.
Good. So if I'm going to find the second term, I will write a sub 2 using the formula 2n minus 3. I'll replace n with 2 and then do the math, which gives me 1. Were you able to complete the first 5 terms using the formula? What's the third term?
3, 5, and 7.
And 7. And if you describe this in English form, what is happening? Are you adding a number starting from negative 1 or subtracting a number starting from 1? Or starting from negative 1? You're adding a number starting from negative 1. And what number are you adding starting from negative 1? 2. So that is basically what is happening here. You're producing the numbers and you're able to describe it using the formula. So that is what sequences and series is all about. It may sound and look too foreign and complicated, but if you're just going to follow the language of mathematics, it's actually really simple. This is the formula. You're producing the first 5 terms and you're doing it mathematically. So this is your sequence. And this is the formula that you use to produce the sequence. That's what we're doing in sequences and series. Looking for the pattern and be able to replicate the pattern. Easy, right? Formula, first 5 terms. Now, what about this one? Can you please do this on your own? Answer the problem now, but this time you have to do it from start to finish. You need to make sure that... Alright, so we're looking for the first 5 terms of the sequence, and the sequence is letting us use this formula. So we need to produce 1, 2, 3, 4, 5 of the sequence using the formula n minus 1, 3n. So it's all about symbols, and you know that if you can read math, you'll be able to solve math. So in this case, what you're reading is you need to produce the 5 numbers or first 5 numbers of the sequence with this formula. And to find it mathematically, although some of you will be able to produce it mentally or without a pen and paper, but mathematically, you're looking for a sub 1 for the first term. So you will replace the n minus 3n with the subscript 1. So n becomes 1, and then you solve it. So you have 1 minus 3, which is negative 2. So that is your first term of the sequence. So in this sequence, you need to produce 4 of them. So you will just do the repetition of the formula, which gives you your complete set. Negative 2, negative 4, negative 6, negative 8, and negative 10. So if we're going to describe the sequence in English, it would be... Are we adding or subtracting? Subtracting. How many numbers are we subtracting? 2, right? We are subtracting 2 from what number? From -2, because it's important to know your first term in every sequence. So the first term is -2, and the rule is you're subtracting 2 for every single number, so you will produce the sequence, which is -2, -4, -6, -8, -10.
So on n, you know, it says it says equal n minus 3n, and the first n, so it will be the same like the other side. It will be 1, 2, 3.
Yes, it'll always be 1, 2, 3, 4, 5. That is why it's called sequences and series. So there's no magic here. It's all about understanding the language of math. And when you're dealing with the language of sequences and series, you always start somewhere. It needs to be a whole number. Most likely you will start at 1. Okay? So that is the general concept of sequence and series, producing the sequence of number based on the formula. And for today, we're going to work backwards. Now, we're able to produce the first 5 terms from the first 2 examples, right? Now, what if the question is, find the 54th term? So does that mean you need to write down all the terms from the first term up until the 54th term to be able to answer this problem? No. So what mathematical strategy are you going to use so you can answer the question?
Plug in the 54 to the end.
Yes. You are going to plug in the 54 to the end because you're not looking for the sequence, you're looking for the specific term in the sequence. And in this case, it's A of 54. That's why symbol is important in mathematics, because it tells you what you're supposed to be doing next. And if you know that finding the 54th term of the sequence is basically finding A sub 54, using the formula, you will replace n by 54, so you will find it. So we have 54 minus 3 times 54. So you will do a little bit of math here because we have 3 times 54 over here. So we have 54 minus, what's 3 times 54?
162.
162. So is our answer going to be a positive number or a negative number?
Negative.
Of course, it's a negative number because we are subtracting a bigger number from a smaller number. And what is that number?
It's 108.
108. And that is the 54th term of the sequence. And again, in math, notations, symbols are important because that's how we communicate mathematically. You don't just write negative 108 without telling your teacher or the people who are seeing your work what it means. So, notation is important because math is a foreign language that you need to learn, and if you can solve math, you need to know how to read math and you need to know how to write math. This is how we write math in sequences and series. Easy, right? So it's all about communication. So mathematics, as abstract as it is, it's actually training you how to communicate well. Because if you cannot communicate mathematically, if you can communicate mathematically, it's a lot easier to communicate with a lot of things because there's a pattern. It's all about the pattern. So find the pattern and you'll be able to communicate mathematically. So the 54th term of the sequence is negative 108. A sub 54 is negative 108. You can describe it in English form or you can describe it in mathematical form. So this is the English description. The math notation is A of 54 is negative 108. Long, short. So in math, you're just learning how to do a lot of abbreviation numerically. So instead of writing it this way, for people who know math, they are already understanding what you're writing out without describing it in words. Okay, and now we're doing this. And if you're watching this video, you can look at this corner and there is an I sign. Click on it because I have videos there that I could share with you so you can practice on all the prerequisite math skills that you need to know to be able to understand what we're doing right now. But anyhow, so we're looking for a sub 28, right? Do you have an answer? What is a sub 28?
It is 53.
53?
Yes.
Let's see. Oh, it is 53. So it is 53, so mathematically you found the 28th term and it is 53 because you did your formula. Now we're looking in a more specific formula in mathematics. We call it arithmetic sequence. And there is a special reason why we call it arithmetic sequence. Because there is a pattern. And in this pattern, we're going to be using this general formula. So all arithmetic sequence follow a certain formula, and our formula will look always like this. So copy it down because you will need the formula. Because we're now going to be producing a specific set of numbers called an arithmetic sequence. Now, as I've mentioned, math is a foreign language and you need to know how to read math. So let's read this because the formula is useless if you cannot read it. In this formula, this is the first term of the sequence, and this is the common difference, which is the special pattern that you need to look for in a sequence of number that fall under arithmetic sequence. So we're going to be using this formula right now because now we're done with the general concept of sequence and series. And now that you have an idea on how to work out problems on sequences and series, we're just going to be more specific this time, and that is for this type of sequence. All right, first, common difference, because that is the special pattern that we're looking for in an arithmetic sequence. You need to know how to find it mathematically. And to find a common difference mathematically, let's say this. This is a sequence with a pattern, and we are going to be looking for a specific pattern in the sequence that should have a common difference. And common difference is just subtracting 7 to 3, 11 through 7, 15 through 11, 19, and 15. And if their differences are all the same and consistent, then it falls under an arithmetic sequence. So let's try. What is 7 minus 3?
4.
4. What is 15 minus 11?
4.
What is 19 minus 15?
4.
So they are all following a certain pattern, and that's what we found. Because in sequences and series, your goal is to find the pattern, and the pattern is this number, positive 4. So now that we know that the common difference is 4, we know that this is an arithmetic sequence. So that sequence right there falls under a special type of sequence. We call it arithmetic sequence, and that is because we have a common difference. Easy. You're just identifying common difference. So, if I have some series of numbers, say this one, does this follow the arithmetic sequence?
Yes.
Why?
It's 4, 4, 4.
Because it's the same example that I showed you a while ago, right? So this one has a common difference of 4, and it is an arithmetic sequence. What about this? This one is new. 2, negative 3, negative 8, negative 13, and the formula is 7 minus 5n. Is this an arithmetic sequence? Yes or no?
No.
No?
Yes.
Yes? Let's see.
Negative 5.
What is 3 or negative 3 minus 2?
Negative 5.
Negative 5. And then we subtract this and that.
Negative 5.
Negative 13 minus negative 8. Right?
Yeah, negative 5.
Which is negative 13 plus 8.
Yeah.
Right? And what is negative 13 plus 8?
Negative 5.
Negative 5.
Because it shrank.
So, is it the same?
Yeah.
So, is this an arithmetic sequence? Yes or no?
Yes.
Yes. And notice that your sequence is shrinking. And what is so special about a shrinking arithmetic sequence, your common difference is going to be negative. So if your sequence is shrinking or going smaller, expect to have a common difference that is negative. And if your sequence is increasing, like problem letter A, expect that your common difference is positive. Okay? It's just another pattern, like rule or pattern to think about when you're dealing with sequence. It's either a positive or a negative. And you know that it's positive or negative by just looking at the sequence without even solving it. Okay, let's solve this. Step 1, is this an arithmetic sequence? Yes or no? And if you don't know, verify it. What's 25 minus 5? What's 25 minus 5? 20. And now we will verify it with 75 and 50. What's 75 minus 50?
25.
So you already violated the rule because there's no common difference. So, is letter C an arithmetic sequence then? No, because the common difference does not exist. Although it has a pattern, because by looking at it, you can pretty much see the pattern multiplying by 5, right? Starting with 5. But that's not the rule that we're looking for. We're looking for a common difference. It needs to be an addition of number from the first term. But since we're multiplying, that's not a special sequence. So this is not an arithmetic sequence. Clear? That's the first skill that you need to learn when you are working with arithmetic sequence, finding the common difference. Why? Because sometimes you will be looking for the specific formula for the sequence, nth term. And when you see the word nth term, it means the general formula for the sequence that will produce that arithmetic sequence. So let's start with this one. We're going to find the arithmetic formula for this arithmetic sequence, and we have some clues to answer this problem. And the clues are, the common difference of this sequence or arithmetic sequence is 3, and the first term is 2. So now that you have two clues, the first term and the common difference, you'll be able to use this formula because all you have to do is to plug it in. What is the first term in this formula? If we are going to use this formula, which one is the symbol we use for the first term?
The first term's the 2.
In this formula, not in the given problem. What is the first term in the formula? A sub 1, right? And what is the common difference in the formula? D. So just like a regular algebra problem, you are substituting the formula the number to the formula. And since we're looking for the nth term, the n's will stay the same. That's the reason why you need to read math. If you're looking for the nth term, that means the n will stay the same because that's what you're looking for. So let's plug in the formula. A sub n is equal to, what is the first term? 2 plus the quantity of n minus 1, because you don't need to replace n. And what is d? 3. And this is now your nth term for the arithmetic sequence. But you know algebra, right? You need to simplify your formula in algebra. Every time you're working with an algebraic expression or equation, always simplify the formula. So how are we going to simplify this? You FOIL or distribute 3 to n minus 1, right? So we will have 2 plus
3n minus 3.
Yes, 3n minus 3. Are we finished simplifying it? What other algebra move can we use to simplify this?
We could add 3 to 2.
We can add 2 to negative 3, right? And what is 2 minus 3? negative 1. So a sub n is equal to 3n minus 1. Can we still simplify this? No. And notice that when you're working with an algebraic expression, your variable should always be on the first term, and your constant will always be at the last term, just to be consistent with the standard form of any polynomials or expression. Although, this one is also a correct answer, but you always want to write it in standard form. Okay? Alright. Formula. Replace a sub 1, replace d, do the algebra, and simplify by combining like terms. So you have 3n minus 1. And what you did was to find the nth term of the arithmetic sequence with two clues, the common difference and the first term. Now, on your own, give me the nth term of this arithmetic sequence. Replace the formula, simplify, and you have the nth term, 5n minus 4. Now, we've learned how to find the nth term of the arithmetic sequence. Now, we're looking for the specific term on the sequence. And when we say specific term, it could be the first, it could be the third, it could be the 240th term of the sequence, and you're able to do this using your formula. So that is what we're going to be looking for now. And how are we going to answer problems like this? Let's have this one. Find the term of the following arithmetic sequence, and the sequence has common difference of 4 with the first term of negative 5, and you need to look for the 13th term. So again, every time you are asking to solve a problem using sequences and series, write the formula of the arithmetic sequence.
So the n is 13.
Yes. Now the n will be replaced with a specific number, because now it's not the nth term, it is the 13th term. So you're looking for a sub 13. So what will happen to our formula when we have a sub 13? That means we will replace this. We will replace this because we have a common difference in the first term. And we can also replace n, because now we're looking for the 13th term and not the nth term. That's the difference between the example on the previous slide and this example. So let's plug it in. A sub 1 is?
Negative 5.
N is?
13.
And D is?
4.
So from an arithmetic sequence problem, now you're just solving a problem involving order of operation.
Yes.
So simplify your answer and give me the 13th term. Did you find it?
Yes.
Okay, I'll find it too. So the first thing that I will do is to simplify this. 13 minus 1? 12, right? And then it turns into multiplication, right? What is... Am I going to minus 5 and 12?
Oh, it's 23.
You need to multiply 12 and 4 first, right?
Yes.
What did you do?
I forgot the
Put the
negative.
negative.
What is 12 times 4?
48.
48. And now you have negative 5 plus 48. So negative 5 plus 48?
43.
43.
So the 13th term of the sequence is 43. So that is the difference between the nth term and the specific term. So whenever you're asked to find the specific term, you need to do the math. Easy, right?
Pay attention to the negative sign.
And pay attention to all the signs and symbols. So on your own, how about this? Find the 93rd term of the sequence. We have 3, 7, 11, 15, and 19, and this is the first term, the second term, the third, the fourth, and the fifth. We're looking for the 93rd term. Are we going to write down the 6th term, the 7th, the 8th, all the way to the 92nd term so we can figure out the 93rd term? Of course not. So how are we going to attack this math problem?
You just rearrange the 92.
Yes, we need a formula, right?
Yeah.
Since we're looking for the 93rd term, are we given the common difference in this problem? Not yet, right? It's not explicitly there, right?
Yeah.
But we need the common difference, right? So we need to find the common difference first. What is the common difference in this problem? 7 minus 3?
4.
15 minus 11?
4.
And this is also 4. So we know that this is an arithmetic sequence and we have a common difference of 4. So if we're going to use the formula a sub n equals a sub 1 plus n minus 1 times d, we have the common difference. We have the n. What is the n here in our formula? 93rd. And what else is missing?
The first term.
The first term. Do we know the first term?
3.
It is given and it's 3. It may not be spelled out for you, but you know that it's the first term because you are given the sequence. So now you have a sub 93 is equal to 3 plus, what is n?
93.
Minus 1 times.
4.
Now, do the math. So the answer is
It's
371.
371. So this is your a sub 93. A lot of mathematics, but you know that if you're given the sequence, you just need to find the common difference and the first term. And in this case, the common difference is going to be 4, because if you subtract 3, 7, 15, 11, and 19 and 15, they're all the same, and that is your common difference. And now that you have the common difference, you just need to know your first term, which is 3, and now you're ready to use the formula, which is a sub 1 plus n minus 1 times d. You could solve for the formula first, and then plug in the value of 93 in your a sub n, or you can use it straight away. And your answer will still be the same. It's still 371. Notice the different approach that I did here?
Yeah.
I find the formula first, and then use the formula afterwards. But it's still the same answer.
That seems like a lot more work.
This may seem like a lot more work, but at least you're able to produce this. So if you're asked to find the 28, the 93rd, the 273, you don't need to repeat the steps over and over and over again, because all you have to do is to use the a sub n. Alright? Recap. In an arithmetic sequence, 1, you need to find or know how to find the nth term and the specific term. And when we say the nth term, it is the formula for that sequence. And if it's the specific term, 93rd, 21st, 2nd, using the formula. Now, 2 sets of problems that you will be given in an arithmetic sequence. Sometimes you will be given the sequence, and sometimes you will be given the clues. And the clues are, here's the first term, and here's the common difference. Figure out the problem. Alright? So, can you give me the 21st term or the 23rd term of this sequence? And that is the 21st term. And you know that your answer is right because you know that the sequence is decreasing. So, if it's decreasing, A21 is going to be a negative that is further down the negative line. So this is how we use your common difference, your first term, your formula to find your A sub 21, which is negative 97. Are you ready for the next one? Ah, we have two special sequences in series in algebra. And again, this is Dr. Esperanza, and thanks so much for sticking with me, and I hope that you learned your lesson on arithmetic and geometric sequence. Please like, share, and subscribe to my channel, and see you all on my next workshop on mathematics. Bye! Bye. Yes, it will only happen for geometric because we're no longer doing arithmetic. So don't overlap your arithmetic and geometric because they have a different